Hello participants, we are going now deeper in micro irrigation engineering subject. I think we have covered more than 30% of this particular course, and we will be dealing exactly on the title of the subject, that is micro irrigation, where drip irrigation is one of the components of micro irrigation. So, we discussed in previous class about micro irrigation and then types of micro irrigation system. Here also we will go talk about introduction and types which are there, and then we will give the importance, brief introduction about drip irrigation system, what are the different types of drip irrigation system and its components. So, when we talk of drip irrigation system, it is the application of water at slow rate, virtually in the form of droplets. It can be applied on the surface or below the surface by using subsurface or surface drip line. On each drip lateral, there are drippers. Now, the principle of water disseminating from drippers, it dissipates the pressure from distribution system by using orifices and following a path of vortex or tortuous. It can be a long flow path, thus allowing a limited volume of water to dissipate from the drip emitter. These drip emitters, what you are seeing here, this is the one kind of drip emitter which is placed inside the lateral line, which we call it as inline drip emitters. This is on-line drip emitter, and then we will discuss when we will come to this particular lecture in coming classes. So, this is on-line type of drip emitter, and here what you see, the water which is coming out of the drip emitter, it is in the form of droplet. So, the emitted water which moves in the soil system, now this soil is unsaturated, means the flow which takes place from the soil system, it is unsaturated flow. Now, in drip irrigation, in principle, one may say the water is supplied from a point source, and then the point source, these point source drip emitters are located at uniform interval. That will depend upon the crop spacing, means plant to plant and row to row spacing, but normally at the interval of 0.5 meter to 1 meter spacing. Now, each source of water creates a moisture pattern which resembles an elliptical or onion shape. Means it will depend, the shape will depend upon the soil texture as well as the amount of water or the rate of flow which is being discharged from an emitter. The soil is saturated close to the point source, with a gradual decrease in the moisture content in the soil in all directions away from the source of water being supplied. Now, moisture content at any location is subject to rate of flow, means what is the discharge from an emitter, and then it is a soil water conducting property, means basically it is a hydraulic conductivity of the soil. Soil diffusivity and conductivity produce final shape of wetting. So, the shape of wetting will depend upon the way the particular type of drip emitter is discharging and then type of soil. So, any lateral, it has a numerous uniformly spaced drip emitters, which will produce series of onion shaped moisture content, and that is closely linked with each other, thus forming a continuous chain of weighted soil masses. So, it makes a uniform water distribution pattern below the soil, which is weighting the root zone of the crop. The size and shape of the chain will depend upon the soil property. Basically, it is the soil texture, and then we can say from the property point of view, it is basically hydraulic conductivity of the soil. The rate of water flow from each point source, the spacing of these sources and the length of time of application, that how long the system drip system has been operated. Now, let us try to see little comparative performance when the water is being allowed to flow from a drip emitter, and when we are comparing with other methods of irrigation. So, if for any soil we are giving two soil moisture constants. So, upper limit of soil moisture constant, which is at which the moisture content is available to the plant, is field capacity, and the lowest most point where plants are not able to withdraw water from the soil is wilting point. Now, these 2 points on an average we give in terms of soil water potential. So, it is at field capacity, it is at 0.33 bar, and this is at 15 bar. Now, when we are applying irrigation, so moisture content, if we are seeing here, it is on the ordinate in y axis, and then days of irrigation, that is we can say this is a irrigation interval. So, irrigation interval, when we see we are taking 3 methods of water application, surface irrigation, then we call it sprinkler irrigation, and then drip method of irrigation. So, when we are comparing, we see that the water which is given in case of surface irrigation system, it is normally it is having large irrigation interval. So, large irrigation interval, when the irrigation water is supplied, it is a field is flooded with the water. So, it takes some time to come to the field capacity, means it is a saturation, then after saturation the gravitational water is removed, the moisture content, it comes to the field capacity, and then it goes to the phase when the soil starts depleting moisture, depletion of moisture through evaporation, through transpiration by the plant. Then what happened? It goes to the drying phase, and means the moisture content, it goes to that phase which is not desirable for the plant. The next phase is next case is sprinkler irrigation system, where irrigation interval is relatively shorter as compared to surface irrigation system. So, there also you find this kind of the cyclic moisture content variation takes place in the soil. So, and moreover, when the water is given through sprinkler system, it is resembling like rainfall. So, the impact of raindrops, it partially seals the soil surface. So, the benefit which plants should have it is not deriving full benefit, but it is giving better response as compared to surface method of irrigation. But in case of drip irrigation system, which we see that irrigation is given almost daily, or in alternate days when we see that moisture content is near field capacity. So, this is the comparative difference how the moisture distribution it takes place in case of three methods of irrigation. So, under drip irrigation the soil moisture level does not drop much beyond field capacity. This is what I was stating in the previous diagram. It means that metric potential is within means it does not exceed the 30 to 50 centibar. So, this is in a very low level, soil moisture tension is not very high. The essential feature of drip irrigation system, it is a frequent irrigation is being given and we are maintaining the uniform amount of water is being given, and then soil water tension is also low. This method provides possibility of establishing a soil moisture regime in which the amplitude of metric and osmotic potential fluctuation during irrigation cycle are limited and in controlled manner. Means we are not allowing, this is what I am telling, that here the potentials are within the control level. The maximum value reached at the end of a cycle may be kept within a narrow range. Now, let us compare or try to know the what are the different types of drip irrigation system. So, here what you are seeing, the pipe, the drip lateral pipeline is laid above the ground level. Here also you see it is laid above the ground level, and emitters are kept on these, means they are attached with the lateral. So, lateral pipelines are laid above the ground level. So, surface drip system uses emitters and lateral lines are laid on soil surface attached above ground on trellis or tree. Now, these drippers can be point source on-line type of dripper, these dripper can be in-line type of dripper. Surface drip irrigation system has been primarily used for wide spacing crops, maybe perennial crop which is of say orchard crops. So, for that surface drip system has been found most suitable, and that maintenance also becomes easier. The discharge rate from these drippers, it varies from 2 liter per hour to 12 liter per hour. So, from a single outlet one can get this range of the water discharge rate, and now these means furthermore which means the discharge rate is maintained below 12 liter per hour, reason being that it should not form runoff. So, it should see that it is less than the infiltration capacity of the soil, so that it does not form runoff. In case of subsurface drip, it is evident from these figures, you can see here very easily that the drip lateral is placed below the ground level. So, the another question is that what should be the depth of placing drip lateral. So, depth of placing drip lateral is at the effective root zone depth, and the drippers in this case is in-line type of dripper. So, drippers are they are fabricated along with the drip lateral. So, at the time of fabrication of lateral, these drippers are placed at appropriate spacing depending upon the crop requirement. So, this method of application is not be confused with sub irrigation. This is another part. In sub irrigation, the water table is controlled. Here in subsurface irrigation, the drip lateral is placed and water is being exactly applied at the root zone depth, whereas in sub irrigation system, water reaches from water table to the plant root zone by capillary action. So, little interference with cultivation or other cultural practices and possibly longer operational life. Yeah, this is the another advantage when we are placing subsurface drip lateral, it does not interfere in interculture operation. So, the life of the drip lateral is relatively more than the surface drip lateral, and this is a typical, you can see this particular what you are seeing, that this is the drip lateral placed below the land surface, and then when water is discharging from the drip lateral, it forms the soil moisture wetting. And so, this is say when the time of application is short. So, this kind of wetting it will form, and then it will continue as long as we keep on the increasing the time of application. So, moisture bulb formation it takes place. Now, so time of application is another equally important thing, that yes, we should apply water such that the crop root zone between the two rows of the plant they get wetted. So, this is a typical how the two rows are being irrigated, two rows of the plant is being irrigated by a single drip lateral, and this is the spacing between the two drip lateral, how they are subsurface drip lateral, it is being shown over here. Now, from coming to the components of drip irrigation system. So, a typical drip irrigation system, it consists of a control head, and then another one is distribution network. Control head, when we say, means we are required to keep all these units which are there under control heads, means there will be pump or overhead tank, then filters, chemical injection equipment, it could be tanks, injectors, backflow prevention device, flow measurement devices, the valves, controllers, pressure regulators, all these are coming under control head, whereas distribution network it consists of main pipeline, sub main pipeline, laterals and emitters. Now, let us see from the figure little more detailed about these components. So, water is to be taken from the source. Now, this source can be a river water, it can be pond water, it can be it can be any lake. Now, here what we are seeing, that there is a canal which is flowing, and from the canal part of this water it brought to a pond, where it is allowed for some certain time. So, that the silt flowing along with canal water, that can be settled here, and then the water is being pumped by using a pump. So, a adequate size of the pump is used, so as to create adequate pressure. Then it goes to a bypass line, where the part of the water, if the size of the pump is more, so part of water it can be allowed to bypass, bring it back to the source, and then there is a NRV, that is a non return valve. So, when there is a when we are using say chemical or any fertilizer, so there is a chance that there may be a reverse flow, and that may contaminate the source of water supply. So, non return valve, its purpose is to see that the water is applied only in one direction. Then it consists, it comes to the sand separator or hydrocyclone filter. This is a filter to remove the impurities. We will discuss about the filter parts in detail in coming lecture. So, this is one kind of a filter. Then it goes to the Venturi injector. This Venturi injector, there are different types of injectors where the fertilizer or chemical which is in dissolved form that can be applied along with the irrigation water. So, after it passes from the Venturi system, it is allowing to suck the fertilizer, then it comes to the sand filter, and after the sand filter it comes to the another filter, that is a screen filter. So, all these filters, sand filter, the sand separator, sand or media filter, or the screen filter, we will discuss in detail. Practically the purpose of filter is to remove the suspended particles which is flowing with irrigation water, and then it comes to the your non-return wall. Then from non-return wall it comes to the main pipeline. So, main pipeline, then from the main pipeline there is a control valve. So, if I want to supply water to this sub main pipeline, so this control valve will be operated, allowed to open or close, and from the sub main pipeline lateral pipelines are attached, and on these lateral pipeline when it can be, as I told you, that it could be placed below the below the soil surface, or it can be placed means above the land surface or below the land surface. So, subsurface or surface drip system, and on these laterals drippers are attached. In order to flush the water from the sub main pipeline, there is a flush valve. Similarly, there will be a flush valve which is attached at the in the main pipeline, and then in order to terminate the lateral pipeline, there is a end plug is attached over here, and from as and when we want to flush the water, clean the drip lateral. So, these end plugs are opened to flush the pipeline. So, this is in brief about this particular diagram. Now, briefly let us try to know that what is the we will select the pump based on the requirement, and then we will also try to see that how much is the pressure requirement which we will need. So, that has to be taken care that while selecting the size of the pump. The electric power unit are internal combustion, diesel engine pumps are also used. So, prime mover is selected based on the availability of the system. Filter, as I told you that there are different types of filter. There could be disc filter, screen filter, disc filter, hydrocyclone filter, and sand filters. They are meant to remove the suspended particles before the water enters in the pipeline. The other the valves etc., they are part of the head control unit to allow the water to pass through, to control the flow into the system. So, these valves are used, and then if there is a air entrapped in the pipeline. So, air relief valves are used. Check valve or non-return valve, as I explained when I was telling you that check valve is basically to make the allow only the particular amount of water control can be made, and non-return valve is to prevent the unwanted reversal of the flow. So, these valves are operated depending on the particular time of operation. Coming to the water distribution network pipeline. So, main pipeline it transport the water within the field and distribute in the sub mains. The main pipeline is made of PVC or, so this is the PVC made pipeline, or it could be made up of high density polyethylene pipeline. Now, pipeline, main pipeline could be of 2 inch, 3 inch, 3 inch as well as 4 inch depending on the requirement. Some main pipeline, these are also made up of PVC or HDP or LDP. Normally, these are PVC or HDP. Their sizes, it will again vary depending on the requirement. It could be from 32 millimeter to 75 millimeter, and pressure is about 4.5 kg per square centimeter. Laterals, as you see, they are made up of LDP, that is a low density polyethylene, or it can be linear low density polyethylene, and these pipelines are 10 millimeter, 12 millimeter and 16 millimeter water. And then on these pipelines, here what you see here, this is a inline type of dripper, it is placed in the lateral pipeline. This is another inline type of tape which you are seeing here, that is also attached, and or it can have online type of drip emitters. Emitters, as the name said, that emitters, the function of emitter is to discharge water, or it is the function is to it is a energy dissipator which reduces the inlet pressure to the extent of which is 0.5 to 1.5 kg square meter atmosphere to 0 atmosphere. And there are different types of drip emitters. So, on this topic we will discuss, but these drip emitters can be pressure compensating, non-pressure compensating, online and as well as inline dripper, adjustable discharge dripper, regulated flow drippers, vortex type of dripper, micro tubing. So, there are different kind of things which are available. Here what you see, this is one kind of a drip emitter, where the inside this. So, there are 3 components we will discuss in detail when we will come to this topic. This is the another one kind of a drip emitter, that is a inline type of dripper which is inserted at the time of fabrication, and these are the what you are seeing, this is a button type of dripper. So, there are variety of drippers which are available commercially, and depending upon the requirement they are being chosen. There are other components which are needed, you can see here there are connecting accessories. You want to change the direction of flow, you can have the means this is one elbow, this is a T, and like this this is one reducer. From this direction water is coming from a larger pipeline, then it is reduced to the another size. So, such type of devices, these are available, and then the you can see here that there is a water regulation kind of a thing, air relief valve, flow control ball valve, and the pressure gauge monitoring system, where we can pressure gauge is there. This is a flush valve to flush the water as well as cleaning of the main or sub main pipeline. Such valves are used, and these are the other accessories which are used for connecting the laterals with the sub main pipeline, or closing this is the end plug which I was telling, this is one end plug. There are when we want to change the direction of flow RT. So, such type of devices are available. When we want to operate the drip irrigation system, means operation of the drip system, it is seen that the water pressure in the drip network, it may be in the order of 2.5 atmosphere, and one should see that the water, when we are required to supply from a drip emitter. So, it should have a atmospheric pressure, operating atmospheric pressure of 1 atmosphere. To apply nutrient materials, fertilizer and all that. So, we need to take care of these nutrient solution, it is a properly dissolved, and then it is being supplied at adequate flow rate. So, these are the points which one should consider for operating, and then the these are the references you can refer in detail for on this topic. And so, let us summarize this lecture. We discussed about the introduction of drip irrigation system, the different types of drip irrigation system and its components. Now, in the forthcoming lecture, we will discuss about the points which are needed for the design of drip irrigation system and its layout in the field. So, thank you very much for patience hearing and attending this lecture.